analyzing the relationship between developed lands, solar energy, and public transportation needs in Minnesota.
Electric energy from solar allows the gain of energy without putting carbon into the atmosphere. Solar is statistically reliable. Solar technology is also quickly advancing and is becoming more viable than ever. It could be the answer towards Minnesota's development as a state sustained by renewable energy.
Shown on the left is the declining cost of photovoltaic cells. They're becoming cheaper and more efficient.
The newly designed BYD electric transit bus uses a non-toxic and environmentally friendly iron phosphate battery alternative to traditional toxic lithium-ion hydrogen batteries. A single charge can provide up to 155 miles worth of transport at 1.92 kilowatt hours per mile, suitable for the majority of public transit needs.
On average, every 12 years, Metro Transit replaces their buses after driven approximately 400,000 miles due to conditioning and usual wear and tear. This means that roughly 33,000 miles are traveled by each bus per year. The Metro Transit fleet currently contains 905 buses, equating to about 30 million miles traveled annually.
Keeping all this in mind, we wanted to find out what the land use requirements for powering Minnesota's buses using solar power would be. A square kilometer of cells would optimally provide 4.6 gigawatt hours of energy a day. Factoring in 20.4% efficiency of the panels, they will yield about 0.9 gigawatt hours of energy a day. This means that in 1 year, this solar array would provide 342 gigawatt hours of energy. Only a fraction of this would be needed to power BYD buses.
BYD buses using 1.92 kilowatt hours per mile at 30 million miles traveled annually would require 58 gigawatt hours of energy a year. This is 17% of the power a 1 square kilometer solar array would produce. This means only 170,000 square meters would be required to sustain all fixed route public buses in a year.
Degraded urban lands, such as paved areas, would be the optimal placement for solar panels because it would not take up undisturbed land. Utilizing GIS mapping, we were able to find exactly where these areas exist in the metro. Ranging from white to red, these colors depict the amount of paved areas. These areas could work, but are not optimal. The optimal areas are depicted in green, which show large and completely paved areas.
The panels on University of St. Thomas's Anderson Student Center currently produce 35,000 kilowatt hours of energy a year. This means that if St. Thomas replaced their current transit bus with a BYD electric bus, it could travel up to 18,000 miles a year.